Wait, think it through for a sec. If you heard me, then you only heard it yourself.
But wait, I love myself.
That was the key, now it's...
Good day, I am Edward M. Barrientos. I'm here to present the importance of system analysis and design. Let me first define what is system analysis. System analysis is the section of system into its component pieces for purposes of studying how those components interact and works. It is the study of current business and information system and the definition of the requirements of the users. It is triggered either by a planned project or by a spontaneously request by a user or owner. Now let's proceed to the importance of system analysis. System analysis is important because it creates opportunity for systematic solution through the numerous tasks needed to complete it. Through these several tasks, a system's overall quality can be updated or improved, and fault can ultimately reduce. It is crucial because algorithms with poor coding might cause the system to crash or demand resources for geometric scaling. System analysis and the application of best practice methodology aid in preventing typical problematic coding practices. The system shouldn't be constructed in a way that seems to be quick and simple, because it only translates to being unstable and inexpensive. Additionally, it is difficult to construct a system in whatever manner appear to be fast and simple, because system development this day places a strong emphasis on system integration, which enable hardware and software from several manufacturers to cooperate in an application.
Describe your university or college as a system. What is the input, the output, the boundary, the component, their interrelationship, the constraints, the purpose, the interfaces, the environment. Draw a diagram of this system. The college as a system, this made up various components known as departments. Each department has its own identity that differs from the others, but they are related because they are part of the same college as must work together to function properly. The prospective students and instructors were the inputs, and the graduate students were the outputs. The school policies serve as boundary, such as wearing proper uniform and having school ID to distinguish yourself as a pamantasan ng kabuya from other school. The college department, faculty, and staff department, human resources, business office, college dean, and executive vice president office were the components. Every department is responsible for the student under their supervision, but they must follow the orders from the higher authorities such as the college dean or school president, which is why the departments are interconnected. The limited number of faculty and staff were constraints. High school transcript, application, tuition, payments, state and federal regulation are the possible input. Outputs include diplomas, transit, billing statement, and inventions. The boundary of university is more difficult to define. Thus, not physical boundary of campus were served or logical boundaries for the organization.
This is the data flow diagram for using an ATM machine. When a consumer inserts their ATM card, the machine checks the access code or PIN number. If the client enters the wrong PIN number, a blank window will appear requiring them to re-enter their PIN number. The transaction will immediately end if you enter the erroneous PIN number. If it's correct, the machine will ask for amount. If you enter the requested amount and there is no available balance in your account, transaction will be completed. The device will display the amount that is currently in your bank account. The transaction will be completed and your available balance will be displayed on the receipt. If you want to print the receipt, the customer will re-enter the desired withdrawal amount and the machine will dispense it to complete the transaction. After you collect the cash, you may choose how you want the transaction's printed receipt to look. Click yes and finish the purchase if you want a printed receipt.
4. How might prototyping be used as part of SDLC? Building software application to prototypes that demonstrate the functionality of product under development but may not contain the exact logic of original software is referred to as software to prototyping. Software prototyping is become increasingly popular as a software development model because it allows for early understanding of customer requirements. Prototyping is the rapid development and testing of new application working models or prototypes in an iterative process that can be used by both system analysis and users. Users can be used the system development life cycle to turn a newly development project into operational ones. Evolution of prototyping. Evolution of prototyping, also known as breadboard prototyping, is based on creating functional prototypes with limited functionality at first. The development prototype serves as the function for future prototypes, upon which the entire system is built. Developing the initial prototypes. This stage, for all intents and purpose, initial prototype basically is called where very basic requirements for all intent and purposes are showcased and user interface for most part are provided in basically big way. The prototyping model is one of the most widely used software development cycle models. This model is used when customers do not know the exact project requirements ahead of time. In this model, prototypes of product is first called test and refined based on customer feedback until the final acceptable prototype is achieved, which serve as the foundation for development final product.
Okay, number 5. Before I start my quick explanation about the difference of the role of a system analyst in SDLC and prototyping, let me first start by knowing what SDLC is. System Development Life Cycle, or SDLC, is how teams deliver quality software at low expenses. It also has a structured workflow which lets it to be utilized with ease. Now, what is the difference? What is the role of a system analyst between the two given topic? In SDLC, the analyst is supposed to tell how a system works in details, and basically their job is to identify, to plan, to interact with the developers, and to conduct testings and how to implement the system built. For prototyping, on the other hand, the analyst helps with the user to help determine what the initial or basic requirements are needed for the system. That's all.